This is a video with extra problems from chapter 17. Let's start by remembering the roulette rules. So there's 38 pockets, 18 red pockets, 18 black pockets, 2 green pockets. Example 3 and 6 says, bet $1 on red 100 times in roulette. If you're correct, you win $1, otherwise you lose your dollar. But let's look carefully at problems 1 and 2 before we start. Number 1 says, how much money do you think you're going to win? How much do you expect to win? Whereas number 2 says, how many times do you expect to win? Do you see the difference in those two statements? The first one, how much money, is talking about the total sum. But verse 2 is talking about counting. It's how many times. So the box that I'm going to do is going to have to be different for both of those. So as we go through, let's do our 3-step process to get to how much you expect to win. First step is find the box. And how many draws you're doing. So we're betting 100 times. So it's going to be the sum of 100 draws. And then let's see what goes in my box. I'm betting on red, so that means I can get red or not red. Okay, because if I get red, I win $1. And if I don't get red, I lose $1. So that'd be -1. Okay, so those are what my tickets are. Now I also need to know how many tickets. So how many chances do you have to win? There's 18 red pockets. So 18 red. And then how many not red? There's 18 black and 2 green. So that means 20 not red. Okay. So there's 18 chances to win, 20 chances to lose. So we win $1 and we lose $1. That's what's in my box. Step 2 is find the average of the box and estimate the box. So average of the box, you just do like 18 times 1 plus 20 times -1 and divide by how many tickets there were, which is 38. That should give you -0.05. And we need to find the SD of the box. Okay, there's not just zeros and ones, so that would take me longer to try and actually find, okay, to put it into Fun with Stats. It's going to be a little bit more difficult. So on this problem, I would just give it to you, a 0.998 to save you time. Step 3. Now that we've done all that, let's find our expected value and standard error. So my expected value is equal to the number of draws times the average of the box. So my number of draws is 100 draws. The average of my box is 0.05. So I get $5. Oh, no. What did I do wrong? Okay. The average of my box, if I put that in my calculator correctly, is -0.05. So 100 times -0.05 gives me -$5, which makes a lot more sense. If you're at the casino, you should be expecting to lose as your expected value. The casino doesn't have games where they don't expect to win overall. And the SC of the sum is equal to the square root of the number of draws times the SD of the box. So the square root of 100 times 0.998 gives me $9.98. Now, it's not required to write this out every time, but I like to write out every time to remind myself of what we're actually finding. So if we play 100 times, we expect in total, by the time, like if you add everything up from the 100 times, to lose about $5, give or take about $10. So really, we might lose like -15 total. We might actually get $5 out of it. Okay? But we expect that we're probably walking away losing money. Let's look at part 2. How many times do you expect to win? First step is you need to find the box. So it's going to still be the sum of 100 draws. Okay, but now my box is going to look different. Now I still have red and not red. Okay, but now if I get a red, I'm going to put in 1 because I'm counting the number of times I win, which I win on a red. And then if I don't win, I just put a 0. Okay, but there's still 18 chances to win on red. So let's write here, win or lose. And there's 20 chances to lose. Okay, so anytime it's counting, it's just 1s and 0s in my box. Step 2 is find the average of the box. I should add up 18 ones, but that takes a long time, so I'll just do 18 times 1. and add up 20 zeros, but again, we'll just write 20 times 0 to save time, and divide by my total of 38, which should give me 0.47. Then we need the SD of the box. Now, this is a box that only has ones and zeros. If you only have ones and zeros, we have that nice little shortcut. So for 1 0 box, it's equal to the square root, and we can write proportions here or fractions, depending on which one's easier for you. I think fractions is going to be easy here. So I'm going to write fractions of ones times the fraction of zeros. So it's going to be the square root fraction of ones. There's 18 out of 38 ones times the fraction of zeros. There's 20 out of 38 zeros. I put that into my calculator and I get 0.499. Now we find the expected value in standard error. So expected value of the sum is equal to the number of draws times the average of the box. So it's going to be 100 draws still times the average of the box, which is 0.47, which gives me 4.7 times, because now we're counting the number of times, so my units is times. And my SCF for the sum is equal to the square root of the number of draws times the SD of the box. So this will be the square root of 100 times the standard deviation that we just found of 0.499, which gives me 4.99, which is almost 5 times. Now, we don't have to round. It was so close to 5 that I think it makes more sense to say give or take 5 times, but you don't have to. And then for my conclusion, it would be, I'm so sorry, it is not 4.7 times. This is what happens when I'm trying to do it in my head to save time. It should be 47 times. That makes much more sense. Okay, which would be almost half if we had 18 out of 38 chances to win. So if we play 100 times, so 100 times, we expect to win about 47 times, give or take 5 times. Now, let's see. Number 3, what is the chance that you win more than $10? Anytime you are talking about sums, and so you want the chance of sums, you have to use the normal curve. So there's lots of different chances we found in this class. We learned about log chances in chapter 13 and 14. But if you are talking about sums or totals, which means sums, and ask you for a chance, you have to be using the normal curve. That's the only way we know how to do it. So the chance to win more than $10, if we want to use the normal curve, we need to go back and find our answers from step 3 when we found our expected value and standard error. Let's see, if we're trying to look at how much we actually win, those would be our answers from number 1. So from up above on number 1, we can say for step 3, we found expected value for the sum was, so just look up above, it was -5. And the standard error for the sum was 9.98. Okay. Now that we know that that's the amounts that we win, that was step 3. Now we do our 3 steps for the normal curve and we just tack them on. So now there's steps 4, 5, and 7, or 4, 5, and 6. So step 4 is we know the sum. And so we draw our picture. We should be centered at -5 as our expected value. We're looking for the chance we win more than $10, so we're way out here. And we're looking for the chance, more means shade to the right. Step 5 is find Z, and we have our nice little Z formula. It's our observed sum minus our expected value of the sum over the standard error. So the observed sum that I'm interested in observing is 10 minus my expected value of -5. Make sure you have that negative in there. Divided by the standard error of, I didn't write the sum. Okay, so standard error of my sum was 9.98. That should be 1.50. Okay, so I redraw my picture. Here's Z equals 1.50, and I want to shade to the right. Now, if I'm shading to the right, we do need an upper bound just to put into our calculator, so we'll say 5 is our upper bound. Then I go to my Fun with Stats bit bucket, and I go to calculator, I go to shade under curves, We're trying to use a z-curve, so that does mean I need to shade under the standard normal curve, which is just the top one there. Notice z equals observed minus, and they still have written average over SD, but since we're working with sums, we do expected value and standard error. My lower bound was 1.50. My upper bound is 5, and it tells me that percentage is 6.68%. So step 6 was find the percent with the calculator. And that is 6.68%. So what that means is that if we play 100 times, we have a 6.68% chance of getting a total of $10 or more because we shaded to the right. Let's see, number 4, very similar, but it says, what is the chance that you come out ahead? So again, chances for sums, for totals, means we have to use our normal curve. Okay, coming out ahead tells me I just want to know, like, I'm trying to find the chance that the sum is greater than 0. Coming out ahead means that you're greater than 0. So again, looks like I'm looking at my total amounts. I'm using the information that we found in number 1. Okay, so same expected value of sum, standard error of the sum, so we can skip straight to step 4 where we know the sum and we're looking for chances. So here's my -5 as my expected value. And I want to find the chance that I get 0 or above. So step 5 is find z. And so z is equal to my observed minus my expected value over my standard error. So my observed that I'm interested in is 0. My expected value is -5. And divide by my standard error of 9.98 should give me 0.5. So that's my z value. I redraw my picture just to help me find my boundaries. So here's z equals 0.5. I'm looking for the area to the right. So I can use 5 as my upper bound. So I go back to my Fun with Stats calculator. And I put in 0.5 as the upper bound. Run, and it's 30.85%. Oh, I always forget to write step 6 first. So find my percent with the calculator. So 30.85%. So if we play 100 times, we have a 30.8% chance of getting a total of 0 or more, or coming out ahead. So if you played 100 times and had a 30% chance of coming out ahead, that would actually be a very friendly game. Most casinos aren't going to give you games that are that friendly to you. Next example, a true-false question has 20 questions. Each correct answer gives 5 points. Each wrong answer scores 0 points. If you guess all the answers, what is your expected score? Give or take how much? Now you'll see on this one, I did give you the average of the box and standard deviation of the box. I think this one's simple enough. I'm going to go ahead and do it with you to practice, but you could just start there. So step 1 is the box. We have 20 questions, so this is going to be the sum of 20 draws. And my box is going to look like this, so we can be correct or wrong. Okay. Let's see, am I counting or doing totals? Like, it's asking me for the score, so this means we're looking for the total, not counting. Okay, if you're correct, you get 5 points. If you're wrong, you get 0 points. How many chances of each are there? Oh, it's true, false. So 1 is correct, 1 is wrong. We don't actually have to put anything different. Step 2 is the average of the box. Okay, which is just going to be 5 plus 0 divided by 2, so 2.5. And then the SD of the box, this is going to be super simple to put into our data analyzer calculator. Okay. So I go back to my calculator. I want the data analyzer. I put in 5, enter, 0, enter, remove that last row, analyze my data, and my SD is 2.5. I always hate the questions where you get the same answer for the average and density, but that's okay. And step 3 is find the expected value of the sum. So that's just going to be the number of draws times the average of the box. So we said 20 draws times the average of 2.5. That gives me 50. And the standard error of the sum equals the square root of the number of draws times the SD of the box. So the square root of 20 times SD, which was also 2.5 unfortunately, gives me 11.2. So after 20 questions, we can expect a total score of about 50 points, give or take 11.2 points. Now keep in mind this does not mean you're going to be exactly 50 or exactly 61.2. We could be anywhere within that range, and really that's only one give or take. So we say one standard error. Let's go ahead and write this down for ourselves. So just like when we were working with regression, we can say we're likely off by one standard error, but we're not surprised as long as we're within 2 standard errors of the expected value. So when I say you're probably going to be about 50 points, give or take 11 points, where really that's the most likely. That's the 68% of the time you're going to be within one standard error. But 95% of the time, you're going to be within 2 standard errors. So really, if you then tie your class to this, like most of them will be within 2 standard errors, so within 22 points of that 50. Okay. So if we ask for likely off by or give or take, that's 1 standard error. If we ask if you're surprised or not, that's 2 standard errors. Okay, example 308. A child plays a game of chance in which he has a 30% chance of scoring 5 points, 50% chance of scoring 3 points, and a 20% chance of scoring 1 point. If she plays the game 20 times, what is her expected score, give or take how much? Okay, again, it tells you the average and standard deviation. You could skip ahead in the video. I'm going to show you how to write this out just because it is such good practice and we're on the video. So for my box, she's playing 20 times. So it's going to be the sum of 20 draws. Okay, double check, is this a total or a counting? What is her expected score? So we're just looking for the total. Okay, let's see. We can get 5 points. We can get 3 points. Or we can get 1 point. That didn't work. Okay, and what are my chances for each? So 30% chance to get 5 points. So that would be 30%, so I just write a 30 usually. 50% chance, I'll just write 50 tickets. And 20%, I'll just write 20. Now you could simplify this if you're going to have to put it into the Fun with Stats. So I would simplify it to 3 tickets of 5, 5 tickets of 3, and 2 tickets of 1, just because that's going to be a lot easier to put into my calculator. So then I go to my calculator. I want to change my data. I just click up on it again. So I have to keep switching. 3 tickets of 5, 5, 5, 5, and then 5 tickets of 3, 1, 2, 3, 4, 5, and then 2 tickets of 1. Now I'm going to mess up on purpose to show you something. So if I put this in and I analyze my data, notice it'll tell me how much I have. So for my 2, it tells me I have 1, 2. That's the frequencies, how many you have. 5 3s, 3 5s. So I needed 3 5s, 5 3s, but oh, I was supposed to have 2 1s. That's not what I had. So I can edit my data and go back. I didn't want a 2. I wanted a 1 and a 1. I needed 2 1s. So now I analyze my data, double check, 2 1s, 5 3s, 3 5s. That looks good. So now my average is 3.2. My standard deviation is 1.4. So step 2, I used my data analyzer. My average on my box equals 3.2. My SD of the box equals 1.4. If I didn't simplify, it would have taken a really long time to type in 35. So that's why I wanted to simplify. Step 3, find the expected value and standard error. So expected value, my sum, is number of draws times the average of the box. So 20 times the average of the box is 3.2. And so that gives me 64. And the standard error of the sum is equal to the square root of the number of draws times the standard deviation of the box. So 20 square root of 20 times 1.4 gives me 6.26. So if she plays 20 times, she can expect a total score of about 64 points, give or take 6.26 points. Now, I just want to point out that over here, when I look at the average and standard deviation in the box, that's my average and standard deviation of the possible outcomes when I play one time. Then I do all this work for the sum to figure out what happens when I play 20 times. Now, what's my total? So just the average and standard deviation, that kind of tells you what to expect with one time. That expected value and standard error tells you what to expect when you play 20 times and you count it all up, you find the total. Let's see, example 309, bet $1 on the number 17 100 times in roulette. If you're correct, you get $35, otherwise you lose your dollar. How much do you expect to win? Give or take how much? Okay. Again, it gives you the average of the box, standard deviation of the box. You could just skip to that point, and you can skip to that point in the video, but I'm going to show you how to actually work it out. Okay, so if we bet $1 on the number 17, well, for the number 17, that means you have one chance, and then there's, if you remember, 38 pockets total, so that means 37 chances to lose. So if we're correct, we get $35, otherwise we lose our $1. So step one for the box, this is going to be the sum of how many times do we play? 100 times, so sum of 100 draws. And it's likely to have this box, so we can win or lose. So we win $35. We lose $1. So 35 to win, -1 to lose. What are my chances? So I have one chance to win, but 37 chances or tickets to lose. Okay, now that we have our box, we could find the average and standard deviation. I don't really want to type -1 37 times into the Fun with Stats data analyzer, and so that's why I just gave you the numbers. So the average of the box, that one I could do by hand though. I just say, well, I need to do 35 plus 37 -1s, but I don't want to write that out, so we'll say 37 times -1 divided by our total of 38, which gives me -0.05. And the SD of the box, that would take too long to type it out into the data analyzer, so I just gave it to you as 5.76. So step 3, expected value of the sum is the number of draws times the average of the box. So 100 times the average of -0.05 gives me, -$5, and the standard error of the sum equals the square root of the number of draws times the standard deviation of the box. And when you put this into the calculator, so it's going to be the square root of 100 times the standard deviation of the box of 5.76. When I put it into my calculator, I make sure the square root only goes to the 100. The square root doesn't go on the 5.76. This should give me 57.6. That is huge. So that means if we play 100 times, so right here, if we play 100 times, we can expect to lose about $5, give or take $57.60. Now, I want to actually go a little bit farther here and just say, okay, we know 68% of the time we should be within one standard error. Let's actually figure out what that range would be. So that would be my -5 plus or minus 1 times 57.6. So if I put in my calculator, -5 minus 57.6, that gives me -$62. And if I add it, I get $52.6. So for this specific bet and these specific ratios and amount you win, a 68% chance that you're either going to lose $60 or like win up to $50. So pretty good chances you'd be within that range. Now, I guess if you want to think about that as the price to pay to play long enough for 100 times, that's probably a whole evening. Maybe you are okay with that risk, but other people might not be okay with that risk. Let's see what happens though for our 95% chance. So that would be -5 plus or minus 2 times the standard error of 57.6. So put that in my calculator. I'm going to say -5 minus 2 times 57.6. So it gives me -120.2. And then if I add it instead, I get 110.2. So this is actually a fairly nice game in the sense that you could almost win as much as you might lose. Okay. If you play 100 times, 95% chance you're either going to like win up to $100 or lose up to $100-ish.